Hi everyone. Today we're on Unit 9, Lesson 1, and we're going to be using the basic trig identities. So there are 7 basic trig identities, 4 of which you already know. We're just going to rewrite them in a different form to have them in our notes. So we know that the tan of theta can be rewritten as sine theta over cosine theta. The cotan theta is cosine theta over sine theta, right? Because cotan is usually 1 over tan theta. Okay. But for our purposes, we're going to use it in the form of sine and cosine. Secant theta, well, that's 1 over cos theta. And cosecant theta is 1 over sine theta. I know last unit we had talked about how when we're setting up the function values for all of our like cosecant, secant, and cotangent, we found the original and flipped it. But in this unit, we're going to be using these identities. So we really want to write them in terms of sine and cosine and leave them the way that they really truly are. And that is as a reciprocal. Okay. The last identity that we're going to kind of reintroduce is cosine squared theta plus sine squared theta equals, and I know most of you know this is equal to 1. Let's just review why this happens again. We know that any given point on a unit circle, the x value is the cosine of that angle, the y value is the sine of that angle. If we make a triangle out of it, cosine, sine, radius of 1, we get cosine squared plus sine squared equals 1. So that's really where this identity comes from. And we have variations of this identity, and you may remember these from last year. Okay, I could, let's say, take cosine squared plus sine squared equal to 1, and I could subtract the cosine from each side and rewrite this in terms, or solve it for sine squared, and that's a new identity. All this is a manipulation of our Pythagorean identity. We could do cosine squared plus sine squared equals 1. This time subtract sine squared from each side. And we wind up with cosine squared theta equals 1 minus sine squared theta. Okay, so again, these are two like manipulations we get when we rearrange that basic Pythagorean identity. And I will point out here, you may notice when I'm working with these trig functions as algebraic functions, it's okay if you want to do that, right? It's okay if you want to shorten it within a problem. Just remember, when you write your final answer, you write it as the actual trig function. Now I have a new identity here. 1 plus tan squared theta equals secant squared. Verify this is true by rewriting both sides in terms of sine and cosine. So I have 1 plus tan squared is sine squared theta over cosine squared theta equals 1 over cosine squared theta. And now what I have to do is I have to use that algebra. I have to use some algebra over here to express this as a single fraction. So I'm going to multiply cosine over cosine. Cosine squared theta plus sine squared theta over cosine squared theta. And I know that cosine squared theta plus sine squared theta equals 1. And so I made them match. Okay, we're going to be doing a little bit more of this tomorrow, making one side match the other, this verify step. Today, we're going to more concentrate on just rewriting and using algebra to simplify things. Now, in this unit, I did not really make a homework packet, so we're going to skip over this question, and this will be a homework question for you. So any question we don't get to on the lesson, I'm going to expect you to finish it up for homework. rewrite each of the following Trig's expressions, sine and or cosine, and completely simplify. Okay, so now here's where we're going to get into treating our trig functions like algebraic functions and doing math to simplify it, doing algebra to simplify them. Sine, cosecant is 1 over sine minus, I have cosine times sine over cosine. And I'm just going to work on now cleaning this guy up. My cosines are going to cancel. 1 over sine minus sine. Now I could do a bunch of different things here. I could write that inside as one fraction, or I could distribute the sine onto each term. I think I'm just going to distribute the sine. Sine times 1 over sine, that's just 1, minus sine squared. And we should remember from the previous page, and if you don't, I just usually, whenever I have things with squares in them, I kind of go back to the Pythagorean identity and see if I can do anything. Well, I know that 1 minus sine squared is really cosine squared theta. And that's what I would get when I simplify that. So we're going to leave this guy as a homework question. Secant squared x minus tan squared x over cosecant x. So I'm just going to rewrite each term. Secant squared is 1 over cos squared minus tan squared is sine squared over cosine squared, all over 1 over sine. I need to simplify this guy, so I need to figure out what my best route would be. We're all going to take a different path. It's not going to matter. I may, since I have a common denominator up top, I'm going to actually combine up top 1 minus sine squared over cosine squared. And I know that 1 minus sine squared is really cosine squared. So in the numerator, I'm going to have a 1. And it's over 1 over sine. So I think I'll flip this guy up. And I wind up with my final answer being sine x. Okay. Again, we could have done it. One person could do it one way, one person could do it the other way. It's just a matter of how you see things. All right, let's go down the left side of the page and we'll kind of leave the right side for homework. Now this middle guy here, just getting a little more complicated. So let's see what's going on. I'm going to start by rewriting every trig function in terms of sine and cosine. Sine, now this is just an alpha. I'm just going to ignore it for a minute. Sine over cosine times 1 plus cotan squared is going to be cosine squared over sine squared. And I'm all over cosine over sine. Well, let's see. I mean, we could, again, there's a lot of different ways we can go. Okay. I think I see a little, I think I might flip this up, right? Dividing by a fraction is like multiplying by the reciprocal. Now I have all times here. Let's see if that helps me at all. So I have sine squared over cosine squared. And inside, I have 1 plus cosine squared over sine squared. Is this going to help? Should I distribute or clean up? I may clean up inside first, meaning I may make this one single fraction, sine squared over sine squared. Sine squared plus cosine squared, I get 1 over sine squared, right? Because my numerator becomes this. And now when I multiply these two together, 1 over cosine squared alpha, which is really, I can write it as one single term with the expression in the numerator as secant squared alpha. And that's all we're kind of doing today. I know it's a little weird, but we're trying to kind of take our more complicated expression and write it as one single expression. Rewrite each of the following as a single, again, still working on the same kind of concept here. Secant theta times cosecant theta minus tan theta. 1 over cosine times 1 over sine minus sine over cosine. So I have 1 over cosine sine minus sine over cosine. I want to combine these together. I want to add the two fractions. I need to get a common denominator. That is cosine times sine. So I'm going to multiply this term by sine over sine. Combine in the numerator 1 minus sine squared over cosine sine. Hopefully we remember cosine squared plus sine squared equals 1. So the top 1 minus sine squared is really cosine squared. One of my cosines is going to cancel out. I'm left with cosine theta over sine theta, which is really cotan theta. One single trigonometric expression. Highlighted as homework. Oh, I think we only have one more example to do together because we're going to leave this guy and this more complicated guy for you guys to try at home. Secant x minus over sine x. So I have 1 over cosine all over sine. That's one of the fractions there. I have a minus in between. 1 over cosine over 1 over sine. So I'm going to work fraction and then my other fraction, and then I'm going to combine them together. Probably the same thing, same approach I would take algebraically. So this guy here, I'm going to multiply top and bottom by cosine to get rid of that fraction in the numerator. That becomes a 1 over cosine sine. Minus, and if I look at this right fraction, this complex fraction, if I want to clear the fraction, oh, I could flip it up. Why don't we do that? We'll just flip this guy up. Dividing by a fraction is like multiplying by the reciprocal. So I have 1 over cosine minus sine over cosine. I have two fractions now. I need to subtract them. So I need to multiply this guy by sine over sine so I can get a common denominator. I can combine any like terms and simplify the numerator. 1 minus sine squared over cosine sine. Again, I wind up with cosine squared over cosine sine. 1's going to cancel. This becomes, what's my variable there? An x. Cosine x over sine x, which I believe that's the answer we got in the previous example. Yes, it is. Cotan x. Okay. So there you go. We're kind of taking a complicated expression and trying to write it as one single trig expression. You can do whatever problems we did not get to on this lesson, and we highlighted them as we went through. Those will be your homework assignment for this evening. Thank you, guys.